Hello everyone. My name is Mandar Dharmadhikari, and I'm discussing today how to implement continuous integration and continuous delivery for a .NET Core Web API, especially using GitHub Action. Little bit about me. My name is Mandar Dharmadhikari. I'm a business and integration uh, architecture associate manager at Accenture in India. I am an integration and Blazor fan, and I blog at my website https fullstackmatty.github.io, and I like to play piano and cook. If you want to follow me on Twitter, my details are given here. I'll share the details over the repository that I have created for this demo, so you guys can go ahead and check out the GitHub Action workflow that sits there. So, what are key takeaways from today's session? So, we'll learn the what and the why of GitHub Action. Basically, what are GitHub Action and why use them? We'll have a look at some of the basic concepts of GitHub Actions. Then we'll discuss a typical CI and continuous delivery flow for a .NET Core Web API, how we can implement that, or rather what the structure should be. And then I'll give you the how, basically the demo of how we do it. I'll point you to the reading resources at the last. So let's start with the what. So GitHub Actions are basically event-driven workflows defined on GitHub repositories. For example, when a developer or an administrator performs an action on the repository, it triggers some event in the background. It can be, for example, when a dev pushes a change to a feature branch, or admin merges pull requests from a feature branch to the main branch or a staging branch, for example. That triggers some of the events in the backend in GitHub. And basically, GitHub Actions are triggered, or rather GitHub Actions tap onto these events to start their workflows. And basically, GitHub Actions can be configured to run on one or multiple events that occur on a repository. For example, we can create a GitHub action which runs when a push is done on a particular repository. For example, when an admin pushes code into the main branch, or we can configure the same workflow to run when a pull request is created from a feature branch to a particular main branch. So one workflow can be triggered by multiple events that can occur on a repository. GitHub Actions provide a simple way of automating many tasks, right from CI/CD pipelines to release management and administration. For example, we can implement continuous integrations for a feature branch wherein we build and test our code using the unit test. Then we can implement the CD pipeline to run when a particular pull request is raised or merged from a feature branch into, let's say, a pre-prod or a staging or a main branch. And we can do other things like we can create workflows which create NuGet packages, or which create, for example, NPM packages, or create different releases. And also, we can do administrations like archiving the old branches, deleting the old branches once the pull request is merged and successfully deployed on the production branch. So there are a lot of tasks we can automate on our GitHub repositories, and it is possible only due to the GitHub Actions. And the next important point is it works as with the many cloud things, it works with pay-as-you-go structure. And the awesome thing is that for you to learn, public repositories always get pre-execution. So there is no limit on how many minutes of workflows you run on your public facing repositories. But if you have your private repositories, then there is certain amount of data. I guess it's around 500 MB and 2000 minutes that you get free with that repository to execute the workflow. So the next question that should come to our mind is, why we should use GitHub Actions, right? There are other CI/CD tools like Jenkins, uh, Circle CI, Azure DevOps. So why use GitHub Actions? So GitHub Action has a tight integration with GitHub repositories, and we know that GitHub is one of the most famous source control management system. And since GitHub Action repositories have a tight integration with GitHub repositories, that makes GitHub Actions the obvious choice for creating integration if you have uh, code in your GitHub repositories. It's easy to set up. Uh, GitHub Actions are written using the YAML files, or rather YAML format. And so once you get a basic hang of how to write these files, it's really easy to set up because it doesn't take that much time. And another advantage that we have of using GitHub Actions is that uh, there are a lot of actions that are created by members of the GitHub Actions community. For example, uh, if we want to post a message to a Slack, there are some actions that are not created by the GitHub people, but people from the community, and they have published them on the GitHub market. We basically just need to reference that particular action into our workflow, and it gets executed in our workflow. So that's the beauty of using GitHub Actions. We have a lot of free actions to use, and even we can write our own actions if we want. Now, let's quickly look at the anatomy of a GitHub workflow, how it is structured. So if we take a look at, so as I mentioned, the workflows are basically event driven. So whenever a particular event occurs, and if a workflow is going to subscribe to that event, it triggers a workflow. Now, a workflow file contains a set of jobs. Now, jobs are basically a collection of steps that are run uh, on a particular repository. So consider these as a set of logical steps. For example, check out a repository, build the code, run the code, and create the publish packages. So this is like a small logical container unit of all this continuous integration steps that we do. So we can club them together into something called as a job. Now, a workflow can have multiple jobs, and those jobs can be executed sequentially, or those jobs can be executed parallelly. And again, we have the ability of, or rather providing information to run a particular set of jobs when a particular job succeeds or fails. So we have that kind of chaining capability provided to us by GitHub. So so in a nutshell, job is a logical container of step of actions that will be executed. And that job, or rather a workflow, can have multiple jobs. Now, one particular job always runs on one runner. So consider runner basically as a VM, wherein the code will be pulled and the necessary steps that we have defined in our job are executed there. So each job gets its own runner. So for example, if there are two jobs in our workflow, those two jobs will be run on, so job one will be run on runner one, and job two will be run on runner two. Now, the problem that arises with this kind of architecture is that in case if we want to share some artifacts that were created during job one, let's say we have created a publish package in job one and we want to deploy to production in job two, then the problem is that since they are running on different machines, we can't share the artifacts between them. So what we need to do is basically upload whatever we create here to upload location, and the job 2, whenever the job 2 starts, it basically downloads those artifacts and then works on them. So this is the GitHub Actions workflow at a very high level. Now, the steps define the low level actions that we can do in our workflow. For example, we can check out a repository, so there is action for that. Or even we can run shell or PowerShell, the bash and PowerShell script commands inside actions too. So this is how a particular job is structured. When we go through the demo, I'll walk you through uh, all the artifacts in detail, what a job looks like or what a step and action looks like. So let's quickly cover a typical CI/CD flow that we can use. So let's say a developer is working on a code and they push the code to the feature branch. So that this particular push event triggers a continuous integration pipeline that is defined on that particular GitHub repository. And that basically, this is what it means, that a GitHub action instance of a GitHub action workflow is triggered. Now the CI pipeline basically builds the code, runs all the unit test cases, uploads the result of the unit test cases. And if the results are okay, what that GitHub action does is basically creates a pull request on the main branch so that we can merge the code from feature branch to the main branch. Now, in real life, we can have multiple branches in between this, like a main branch, a staging branch, and then the feature branch is created from a staging branch. So this can change. I'm just taking two branches for the example. So once the pull request is raised on main, the reviewer basically reviews the pull request, whether everything is good. They check the artifacts and whether the test results are successful or not, or in case of the staging environment, they can run some external test suites they have. And if everything is okay, the administrator or reviewer, if they are different, they can merge the code into the main branch. So once the code is merged into the main branch, it again triggers another continuous delivery pipeline, which basically deploys your code to the Azure. Now, in our demo, uh, whenever this merge happens, we are going to deploy the code in stages. So when the merge happens, it deploys the code to the pre-prod, or rather it builds the code first. Then there is a job which deploys the code to the pre-production branch. Now this requires approval from the reviewers that yes, there is a job that wants to deploy this web API to pre-prod environment. So if the approver approves it, the artifacts are then deployed to the pre-production. After that, if another set of approval is provided after testing, then the job gets deployed to a deployment slot attached to the production. And if that is successful, as a final step, the swap happens between the actual production web API slot and the warm-up slot. So we'll see this in action just in a minute. So this is how basically a typical CI/CD workflow will look for our demo. So I'll quickly move on to the demo because that's where I want to spend some time discussing it. So this, or rather the code that I've created today for our demonstration is basically a simple web API. So what this web API does is there is this very famous web API called as Pokemon web API, which gives you details about the Pokemon used in the various Pokemon games. So what I have done is basically I have written a .NET Core web API which acts as a wrapper over it and exposes a facade for the Pokemon web API. So if I have to show you how this works, so here, so it basically has two endpoints. So whenever you specify a name of the Pokemon, it will give you all the details about the Pokemon. And if we provide an ability ID, it basically goes to the backend Pokemon API and it gives us back the ID. Let me see if I can put that Pokemon API. So this is the original API, and the web API that I've written in .NET Core serves as a facade over it. So if I have to test it, all I need to do is just send a name of a Pokemon. So let's Once we do that, it gives us the details like the name of the Pokemon, the moves it can make, and a various list of its abilities at the end. So it's not a fancy web API, it's just basically a wrapper API. And what it has is it has a test of, or rather a suite of unit tests. So if I can find, yeah. So we have the test for checking various things inside our code. So we have test for checking the HTTP client returns correct responses or not. We have tests to check whether the automapper profile maps the correct objects and correct values or not. So it's standard code and a unit test project. And this is what we will deploy into our production environment today. And another thing that I want to add here is under test assets, I have a Postman collection, which basically runs a set of tests on the deployed API, either on the pre-production or a production set. So that integration test looks something like this. So it's basically making a call to the resources, providing the Pokemon name, and then asserting certain things like whether the status code was set 200, whether correct names were returned or not, right? So there are three set of tests for this. So this is what we will use to run as our integration tests. So the unit tests will be executed as a part of a CI pipeline or continuous integration pipeline, just to ensure that our code is compiled correctly and that we have not broken anything. That's why we have the unit test. And once the code is deployed to an environment, we will run the integration test using the Postman collection, just to ensure that the web API is giving us the responses that we are expecting. So that's the code basically. So let's quickly go to Azure first. So this is the app service that I've, rather the web app that I've created for it, and it is running on a production level app service plan. So basically, it allows me the ability to create slots. So what I've done is I've created two slots. One is called pre-prod, and one is called prod warm-up. So our continuous delivery pipeline basically deploys the code after approval to the pre-prod first. Then someone can go and run the integration test. And then again, it asks us for the approval to deploy it to the production warm-up. And if a necessary set of approvals is received, then it deploys it to warm-up. Now the warm-up slot is associated with the production slot. So whenever we deploy it to the warm-up slot, it basically warms up the slot, and then we basically do a switch over between the production and the warm-up slot, so that there is no downtime for this, and we actually have a backup for whatever was deployed to the production in the first time. In case if we find that after making a swap between this warm-up and a production slot, if things are not working according to our plan, we just do a reverse swap so that the production code gets reverted back to what it was before the swapping. So this is what we will do today with the GitHub Actions. So let me go to Visual Studio once again. Now, whenever we want to define, so now I'm moving on to the pipelines now. Now, whenever we want to define the GitHub action pipelines for our workflows, our repositories, we have to do it inside the repository itself. So we will have a dedicated folder called .github/workflows, and inside that workflows, we'll have different pipelines defined here. So for example, in today's demo, we have two pipelines. One is called a CI pipeline and one is production deployment pipeline. So our CI pipeline, let's take a look at it. Let's take a look at the structure. Let me just stop this app first. So let's take a look at this pipeline. So basically, we provide a name first, that it's called a CI pipeline. Now this is where we define the event on which this workflow will be triggered, right? So it is saying that on the action called as push, basically what I want to check is that when a push happens on any branch which starts with the word feature, so it can be feature 1, feature 2, feature 3, feature X, like that, this workflow will be triggered. So any push that is made on any branch which starts with the word feature, this workflow gets triggered, right? And what it is saying that do not trigger the workflow. So paths.ignore basically specifies that I do not want my workflow triggered whenever any changes are made to either git ignore or readme file, because those are not actually the changes that will get deployed to the any particular environment, right? Then comes the actual cream of the job, wherein we will define what exactly what we want to do, right? As I mentioned earlier, that is defined inside a job. So a job is, so jobs contain a list of multiple jobs. So for example, in this CI pipeline, we have two jobs. One is build and test, and another is called as create a pull request. So a particular job we define where it runs. So we are saying that run this job on a Ubuntu latest version uh, machine which has a latest version of Ubuntu. We have provided some environment path local to the particular job, which basically says that I want to build the solution which is placed at this location. So inside source folder, there is this solution file called as okapi.facade.slm. So I'm basically going to tell .NET to build this. Now we are going to specify the actual steps that we want to do inside this job, right? It is just the high level idea where the job will run and any environment variable that we want. Now the actual steps are that on the particular machine on which the job is initiated, we check out the repository so that we have the code. So this checkout repository uses the action from the GitHub marketplace called as checkout version 2. So what it will do is basically it will check out whatever branch that we have defined here, right? So if this workflow is triggered by a feature one branch, that feature one branch gets checked out. If the workflow is defined by a feature two branch, that particular branch gets checked out. Or we can specify a particular branch here, that if we want to check out that particular branch. Now, once the code is checked out, what we do is basically set up or install the .NET SDK on that runner. Now, the advantage of using shared runner in GitHub Actions is that in case if someone has already or just previously used that machine and they have called a particular task like say setup.net version 3.1.x, right? So if someone whose workflow ran before mine on that particular VM, if the .NET environment is already installed on it, the GitHub Actions will not actually install it, but use the same environment. If the versions are different, it goes ahead and changes the, or rather installs the .NET or npm or for any assets for that matter. So basically, once we check out the repository and then we install the .NET and then we build the code, and all these steps are being executed sequentially in order that they are defined. They are not executed parallelly. So once the .NET is installed, we basically run, rather build the project using the solution path that we just provide. So we are saying that build this solution, and since this solution already includes the projects that to build, it will automatically build these projects. Yeah. And once that is done, I want to run the unit test. Now the X unit basically generates a report for us, which we can see how many tests were successful, how many failed. So basically what I'm doing here is I'm creating a directory to upload those test results so that someone at a later point in time can actually check them, right? And then once the directory is created, I'm saying that run the .NET test on the test project that is found inside this solution. My logger is of type HTML, and I'm saying that when the test is run, upload or rather create the test results inside this particular test results folder. And once this step is done, the last part of this job is to upload those test reports to the common folder. Now, once that is done, this job is finished. That means that the instance is removed from that particular VM. Now the workflow checks that, yes, I have another job, which is called create a pull request. Now here again it runs on Ubuntu VM with Ubuntu latest. If the Ubuntu latest is not one we want, we can use Windows servers or even Mac for that matter. Now here the crux here, it says that it needs the build and test job to run successfully. So if this job runs successfully, then only this particular job is triggered. If it fails, it is not triggered. And if we don't specify this needs element here, what it will, or rather what GitHub Actions will do is it will create these two jobs on two different VMs and run them parallelly. So since we want the pull request to be created only after the tests are, or rather the unit tests are passed and the code is properly built, that's why we use this needs to make the execution of the jobs sequential. So the step inside is inside this is basically I'm using the action from a community which is called as reposing pull request version 2. So someone has already written this thing, and it says that check out this particular branch and create a pull request, and I just specify the reviewer for the pull request, message, and the title, and it is using the by default GitHub token that is available to every workflow. So in order to see this in action, so what I'm going to do now is I'm going to show you the demo, and we'll see this workflow get executed in real time. So I'm just going to do a cheat commit in here. This is here. I'm going to sync this. Let's go back to our repository. Now, whatever actions that we have defined inside this workflow, they pop up here. So we have two workflows defined in our code, the CI pipeline and the production deployment pipeline. So we can see them listed here. Now we can see here in the middle window that a workflow is running on feature one branch, and the workflow name is CI pipeline, and it gives us the commit details. So if I click on it, it basically gives me the commit details and whatever changes that I've made. So our workflow is like this. So this needs word that I just described here in the end. So this need words, as I said, it forces the jobs to run sequentially. So this is what we can see here. That was the build and test job was run, and then the create pull request was run on another machine. So this one runs on one machine. If it is successful, this particular create pull request runs on another machine, and the job has uploaded one artifact called as test run reports for us. So if we want to drill down on what happened inside each of the steps, so you'll see that whatever we define here in the workflow, the steps, those are visible to us here. Like we checked out the repository, so we can check the log for it, what was going on. We can check what was going on with the .NET. It was installing the .NET. Then we can check the output for building, and so on and so forth. So now what, and the create pull request basically says that it creates a pull request using the community action that I just mentioned. So it pulls the action from the community repository, or rather the repository of the person who has created that particular action. It builds that action and then runs the other pieces of code. Now, to check this, whether our pull request was created or not, you'll see that a pull request is created here. So if we click on it, it gives us details like that the GitHub Actions bot has created on it, and with a message that web API bot raised the PR, and it basically adds the badge called as auto PR to this. And now the interesting thing is that even though this pull request is raised, and we can see that I have been assigned as a reviewer to this particular pull request, since I am the only one working on this repository. So I'm the reviewer, I'm the uh, one who pushes the code. But we can see that this particular repository requires my review. Now, if we check at the merge window where we are allowed, or rather admin is allowed to merge it, it says that merging is blocked because we want one approving review. And it says that all checked has passed. So what check it is basically doing is that there is this check called as build and test. So it says that this build and test should be passed inside the workflow before this repository can actually be merged. So for example, if someone pushes in a code which is bad, which is not compiling properly, or the unit tests are failing, this check would fail in the pipeline, CI pipeline, and we would not be allowed to merge this repository. So how I have done this is basically I have enabled something called as protection rules on the branches. So I've said that I've defined a protection rule for my main branch. So it basically says that whenever someone is trying to raise a pull request onto a main branch, or even raising a pull request on the main branch, I say that I require at least one reviewer for this. So we can specify a maximum of 6 reviewers, and we can assign those reviewers while creating the pull request. Now I'm saying that if a new pull request is raised by a particular person, then dismiss all the stale pull requests where approval is required, and then require review from code owners. So it means that whenever a pull request is created, the code owner should review it first. So this is just to ensure that no one is actually making bad pull requests or bad commits to the main branch. Now, what I've done is that the CI pipeline defines a bunch of jobs like build and test, create pull request. The production deployment pipeline has its own set of jobs. So those jobs, once the flow is run once on the repository, those pop up here, and we can define whatever status checks are required while creating pull request or merging into the main branch. So I'm saying that whenever a pull request is created, it should pass the build and test job, which is basically that the code is compilable and that the unit tests are successfully run. That's it. That's how the pull request gets created, and that's why we have this message called merging is blocked. So when I provide a review to this, we will be allowed to merge. So before I do that, in real life, what I would do is go to this, download the test run results, and let's say I want to extract them. I will go quickly here. I would go see what were the details here, that the pass percentage was 100, everything. Now, if everything is okay according to me or any reviewer to whom the review is being assigned, what they can do is basically go to the pull request again and add a review here. So if they find everything is okay, they can say that okay, approved. Or if they want any changes based upon whatever they see here or whatever the commit request they see here, they can request changes to this. So this again goes back to the developer. So for the time being, let's approve the change, and I'm submitting the review. Now you can see that all the checks have passed and the changes are approved. And it says that there are no conflicts with the base branch. So all we'll do is merge the pull request. So I'll say merge accepted. I'll confirm the merge. Now, what I have defined is there is another workflow called as production deployment pipeline, which got triggered when I merged the pull request. Now, let's look at this particular merge, or rather this particular deployment workflow, what it does. So this one is a little bit complex. So it says that it runs basically when a push is made on the main branch. And I'm saying that don't run the workflow when there is a change made to any of the MD files or gitignore files or anything inside the integration test project. I've defined certain common parameters which are used across multiple jobs. So this is another advantage of using environment variables at the top level of workflow. So whenever a job is run, the GitHub Actions itself goes and populates those environment variables in each and every one of the VMs where the job runs. So if we specify this at the top end, all of these environment variables will be created on every VM that is used inside this list of jobs. So the first one is basically build and unit test job inside here. So what it does is basically again checks out the code, sets up the .NET, builds the code, and then create a directory for uploading test results, run the unit tests again. So whatever we did in the CI pipeline, and it uploads the test results to a zip folder called as test run reports. Now the other thing that this does is, in addition to the CI pipeline, is that it creates a publish package for this particular web app. So what it does is basically runs the .NET publish, and it's saying that I want to create a package for the release configuration, and I want the package to be created at this folder on the any VM where the workflow is run. So what basically it does is it creates a set of package files, and the next step is it uploads them to the same folder on the common storage from which all the jobs can access. So if we go back to a production pipeline, we'll see that the first job was successfully run, that it has created and uploaded all the published app. Now what I've done is that I have set up approval workflows for this. So GitHub recently allowed us to do approval-based workflows for continuous delivery. So what I've done is basically provided two environments here called as pre-prod and prod warm-up, similar to the slots that we have here in the web API. And it basically tells us that we require someone to review this deployment and provide approval before we can actually deploy it. And that only main branch can deploy to this environment, this pre-prod environment and prod warm-up. And that we have any secrets that we are using while deploying to the Azure portal, those secrets can be stored according to the environments. So I have two environments here, one to deploy to pre-production and one to deploy to production warm-up. Now, because of this rule, the action now, if we take a look at it, it says that the action is now in the waiting state, because it says that I have requested a review from this. So what I have to do here is review the deployment. So what we can do at this stage is basically approve the deployment or run some tests on the environment. And if they are successful, then basically we say approve. So this step is where testers can provide approvals after doing end-to-end testing. So let's say I approve it, and it will keep on. So it will queue up and it will pick up the task now and should start running. Now see the status change to queue. So ideally the status should change to in progress now. So let's look at what this deployment does. It basically says that, so right now it's running this deploy to pre-prod job. It says that what it runs on Ubuntu latest, and it again says that run this job after only the build and unit test is successful. And we have defined that I want to use the environment pre-prod, which we defined in here under our settings here. And the steps are basically download the artifact, or rather whatever we have published, the publish package, download it, and deploy it to pre-prod app service slot. So it basically deploys it using the Azure Web App Deploy. And the main thing that it requires is called as a publish profile. So the way we can get a publish profile for a web API is go to the overview, and we can download the publish profile for each and every slot. So this gives you the publish profile for the production slot. We go down to the individual slot. We can download those publish profiles, and all we need to do is basically save them as a secret inside here. So I have Azure publish profile here, and I have copied whatever I get from the get published profile into that secret, and that's it. That's all we need to do. So basically, we call the action web apps deploy version 2, and we provide the name of the app where we want to deploy it, the secret, and the name of the slot. So we have defined everything here at the top. So our name of the app is web OK Facade API. The name of the pre-prod slot is basically this. So it will deploy that to the pre-production slot. So if everything is good, in our actions, the task should be complete for us. See, the second task is now run. I have received the URL for this. And as a part of this task, I have already run the Postman collection for this here. So once the app is deployed, what I'm doing after that is I'm installing Node on the here. And then I use the command line utility called Newman, which runs the Postman collection. And we are basically running the Postman collection and uploading the results for a later view, right? So that's how this job looks. The deploy to pre-production, the production warm-up slot does exactly the same. The only difference is that here we use the environment pre-prod. In the next step, we are using the prod warm-up. So both of them have different publish profiles. So based upon the publish profile, the deploy action actually deploys it to that particular slot. So since we have again defined a protection rule on this particular environment, what it does is I need to again approve this. So I say approve. And then again, the whole delivery pipeline kicks into play. So again, it goes into queued, and once it gets a server, it goes into in progress. So let's see what happens here. So it's setting up the job. It is now downloading the artifact that the first job uploaded after running .NET Publish. So now it is deploying to the prod warm-up slot, which is this particular slot. So the changes will be deployed to this. And if the changes are successful, then the swap will happen between this and the production one, so that the code actually gets pushed to the production and the production code comes to this particular prod warm-up. So let's move back here. So now it has deployed it to the production warm-up slot. Now it's installing the Newman, and soon it will run the integration tests. So let's wait for it. This steps generally takes some time. And it's now running the integration tests. So it created the folder where the test result will be uploaded. And it has uploaded the result, and now it's cleaning up the repository and runs the cleanup job, whatever happens after that. Now, as this job was successful, there is this actual job which actually deploys to the production. So what that does is basically says that I will deploy this only after this job is successful, run this on Ubuntu latest, and I want to deploy it into this particular resource group. So what it does is it logs on to Azure using Azure login action, and basically runs this command called as az web app deployment slot swap. So it performs a swap between the production warm-up slot and the target slot is a production slot for us. So all of them are defined here at the top. So we have the production slot name and the production warm-up slot name. So it basically does a swap out over it. And once the swap is complete, it logs out of Azure. That's it. So right now it's swapping the slot. Now the way it logs into Azure is basically I have to create a service principal for it, and I have to set it up inside a secrets. So it's called as it's set up on a repository level. It's called as Azure credentials. So what I need to do is basically create a service principal for this, download that particular service principal profile, save it inside this variable, and the workflow picks it up from here. So we don't have to actually save any passwords in our workflow. That's the advantage of using secrets here. So if everything is good, we can see that every step was successful, and we can see the URL to which it was deployed. So we can let's see. We can see that it deployed it to the pre-prod slot. Similarly, this one deploys it to the production warm-up slot, and then the actual slot swap happens between the warm-up and the actual production slot. Now, if we go down here, we can see that we have received these reports. So these are the integration test reports for the pre-prod environment, for the prod warm-up, the test reports for the build and test job, and the published web app, which was published. So let's take a look at this one. So here, so you can see the reports for the tests that were run. We can deep into this, the total iterations that were run, the total assertions made, total requests made, so on and so forth. So we get a nice view of what happens in our deployment. So in case if you want to break it into multiple chunks of multiple merge and pull requests between multiple branches like the main, the pre-prod, the staging, we can always do that. That way we can set up the approval workflows for each of the branches, check the artifacts that were uploaded by each branch, and then approve the actual deployment so that uh, everything runs smoothly. This is how generally we can deploy a web API to production using a GitHub action. I think that's all. I know it was quite a heavy demo, but if you have any questions for me, just shoot now. That's the end of my demo. By the way, this is my GitHub repository name, and this particular repository is available there. So if anyone wants to study the way the workflows were written at a later point in time, just go to Full Stack Madi on GitHub, and that should give you the location. This is the project called as Web API CI/CD GitHub Action, and you can study the workflows in here. If anyone has any questions, let me know.